Alrighty guys, quick little final video to answer this question and go over Le Chatelier's principle. So there are three things that can change the direction of the reaction, increasing or decreasing the concentration of reactants or products, adding or removing them, changing the reaction volume or pressure in the case of gaseous equations, and changing the temperature. So in this equation here, we have a totally gaseous equation. Everything's in a gas, so it's homogeneous. It is exothermic. The delta H is negative. And there's a series of different things that it's giving us and is asking which way would the reaction shift with each change. All right, so the first one, adding oxygen. If we were to add more oxygen, all right, then we're going to have more reactant. We'll be able to make more product. When you add something to one side, you shift it towards the other side. So this would shift the reaction right, or you could also say toward product. Or you could simply write an arrow to the right. Those are three different ways you might see the answer asked for or presented. All of them mean the same thing. If we increase the temperature, all right, this is an exothermic reaction, so we can think of heat as a product. If we increase temperature, that's like adding more heat. If we add heat, it's a product, then we're going to shift it towards the reactants. So in this case, we would shift it left toward reactants. Remove SO3. SO3 is a product. If we remove the product, all right, then we basically need to replace what we removed. If we remove something, then we are going to need to replace it. So if you remove a substance, then you're going to shift it toward that substance. So that's going to shift the reaction right toward the product. Or like this. I'm going to start using arrows now for my answers. All right, if we remove SO2, SO2 is a reactant. If we remove a reactant, we're going to shift it towards the reactants. If we decrease the temperature, well, we could just look at our answer to B. We know if we increase the temperature, we shift it left. So if we decrease the temperature, we're going to shift it right. But if we think about this conceptually, if we remember that we had heat over here as a product, if we decrease the temperature, we're removing heat. We're removing a product, so we're going to shift toward that side. If we increase the volume, so remember for volume, if we increase the volume, that's the same as reducing pressure, okay? And so in this case, it's going to go toward the side with fewer, for increasing pressure, it's going to go toward the sides with, for decreasing pressure, it's going to go toward the side with more moles of gas. If you increase pressure, it's going to go to the side with fewer moles. If you decrease the pressure, it goes to the side with less moles. Well, there's 2 plus 1, so 3 moles on this side, 2 moles. So there's 3 moles of gas on this side of the equation, 2 moles of gas on this side of the equation. So it will go towards the reactant side, the side with more moles of gas. All right, if we add an inert gas, so add some gas that will just fill up space and cause pressure, create pressure, but not actually be involved in this reaction, it doesn't react, all right, then adding an inert gas is another way to increase pressure. If we increase pressure, it will go toward the side with fewer moles, which is the product side. Okay, and that's all the different ways that Le Chatelier's principle can be applied. Changing temperature, changing the concentration of product or reactant, or changing the volume/pressure with a gaseous equation. And that's the end of chapter 15.